Right then, rates of change. What do we mean by rates of change? All it means is how much a variable changes with respect to a different variable. In physics, you will hear the word rate used a lot, and it will nearly always mean per unit time. For example, current is the rate of flow of charge. Velocity is the rate of change of displacement. Acceleration is the rate of change of velocity. And you get other things like force is the rate of change of momentum, right? So in physics, rate of change means per unit time, pretty much. In maths, because you're plotting on a Cartesian axis, so you have a y-axis and an x-axis, when we say rate of change of a function, what we are talking about is how much the output of that function, f of x, changes with respect to the input, x. So when we say gradient, we often, at A level, will be referring to dy by dx. So if you have a curve, then how steep that curve is depends on how much the y value changes with respect to x. And so here I've drawn a very bad convex graph that has a negative gradient here, it's stationary there, and a positive gradient here. When you're talking about the second order derivative, d squared y by dx squared, what we are saying then is, what is the rate of change of the gradient? Because if you want d squared y by dx squared, you need to differentiate dy by dx with respect to x. So we are asking the question, how does my gradient change? Well, for this function that I've drawn, my gradient starts off negative, is stationary at the bottom, and then becomes positive. So how would I describe the rate of change of my gradient? I would say, well, it's going from negative to positive, so the rate of change of it is greater than 0. And you can clearly see the graph is a minimum. That is why the rules exist that if d squared y over dx squared is greater than 0, you get a minimum. And if it's less than 0, it's a maximum. It's not because of any change of sign, because often people think, oh, well, if it's greater than 0, it's positive, must be a maximum. But we are saying that the gradient is changing and getting more positive. The only way that that can occur is if it starts negative and becomes positive, clearly a minimum. If the rate of change of the gradient is negative, the only way you can get that is if your gradient is positive, becoming negative, that is going to get you a maximum. So I just wanted to explain where the rule comes from for second order derivatives, and I have missed one because we can introduce an equal sign. Well, what happens? Well, let's think about it. We are asking ourselves what is happening to the gradient. If the rate of change of the gradient is 0, then the gradient, dy by dx, must be a constant, because the differential of any constant is 0. Therefore, if your gradient is constant, you are going to have a point of inflection. So, for example, a cubic graph, right, that there is where you have a concave curve changing to a convex curve, and the gradient is actually a constant at that point, instantaneously, but it is a constant. And so that is why d squared y by dx squared equals 0, is a point of inflection. I hope that helps. Please let me know in the comments if there's anything else you'd like me to cover, and I'll do my best to, and I'll see you around. Cheers.